Today we're looking at a practice paper for level 3 and it's one of the calculus ones. It's Achievement Standard 9178 and that is the paper on differentiation. Question 1 asks us to differentiate sec 6x. So sec goes to sec tan, that's on your formula sheet, and the 6x in it means that we have to multiply the front by the derivative of what's inside. That's the chain rule, so it's 6 sec 6x tan 6x. For part B, find the gradient. So gradient means we are finding dy by dx of y equals 3x. Well, I'm going to write this actually as 3x plus 1 to the power of a quarter, so it's easier to see what we do to differentiate. So we have the chain rule. We've got a quarter, 3x plus 1, reduce the quarter by 1. Now be careful here. Taking 1 off a quarter makes it minus 3/4. And then you times it by the derivative of the inside, which is 3. So we end up with it being 3/4 at the front there. Okay, and we want to find that derivative at the point 5, 2. So when x equals 5, dy by dx equals 3/4, 3 times 5 plus 1 to the power of minus 3/4. And that comes to 3/32. Part C, we want to show the slope of the tangent to this curve is always positive. So if we're looking for the slope of the tangent, that again is the derivative of the curve. So that derivative of this one, this is 1 minus 2x to the minus 3. So that becomes minus 3, 1 minus 2x, reduce that power by 1 and times by the derivative of the inside. So that becomes 6 over 1 minus 2x to the 4. And then you need to put some explanation about how that's always positive. So we have that 1 minus 2x to the power of 4 at the bottom. Now because it's to the power of 4, that will always be positive. Even powers will always give you a positive result. Therefore that gradient will always be positive. Now we have a question on rates of change. We've got a rocket launching from the ground and this triangle set up defining some of those bits of information. So we've got the angle of elevation is theta. It's increasing at a rate of 0.05 radians per second. What rate is the height of the rocket changing when theta is pi by 3? So let's start by writing down the things we know. So we know d theta by dt, so that's the rate that theta is changing is 0.05. The thing that we want to work out is the rate that the height is changing, so we want dh by dt. So we need something that's going to link h and theta, and we can get that from the triangle itself since we've got a right-angled triangle here, and tan theta would be equal to h over 3, or in other words h equals 3 tan theta. So back to dh by d theta, if we start with dh by dt, start with the thing that we know. How can we create the thing that we need? We need to times it by, well, we need to introduce an h on the top to get the dh over dt there. We've got the dt on the bottom by the d theta over dt, but we need to cancel the d theta. So we need this part just here. Okay, so from this, actually I'm just going to move it out of the way just a teeny bit. We'll pop that down there. And we'll do dh by d theta just up here. So differentiate this with respect to theta, and differentiating tan is on your formula sheet. That becomes sec squared theta. So dh by d theta will be dt by d theta, which was 0.05, times by 3 sec squared theta. And we want to work that out when theta is pi by 3. dh by d theta by dt equals 0.05 times 3 sec squared of pi by 3. Now for putting this into a calculator, just remember that sec squared is 1 over cos. So when you're putting this in, you actually need to do it as 1 over cos into your calculator. I'll just show you that one actually, it'd be quite helpful. So it goes in like this, and there's your 3 over cos pi by 3 squared. and that comes to 0.6. Final thing is to put the units on it. So this distance was, we're measuring the change of distance over time. So the distance was being measured in kilometers and the time was in seconds. So this is kilometers per second. For part E, we've got a curve and we're considering the tangents at 2 different points. We want to find the coordinates where those tangents intersect and show that the angle between them is a right angle. So we're going to need the equation of those tangents. So we need the gradient. And looking at this, actually we're going to use the quotient rule here. So let's set up u is pi sine x, v is x, so du by dx and dv by dx. We get pi cos x and 1, so dy by dx is v du by dx, so x pi cos x minus u dv by dx, that's pi sine x all over v squared. Now we're doing the tangents at pi and minus pi, so when x is pi, that gradient will be, well, we get cos pi is minus 1 and sine pi is 0, so we end up with x where x is pi, so we get pi times pi is pi squared, cos is minus 1, so it'd be minus pi squared, sine x is 0 over pi squared, so we end up with the gradient is minus 1. When x is minus pi, going through the same process, putting those in, we will get that the gradient is 1. So we've got the gradients. We also need a point on the curve. We've got the x value and we'll use that to work out the y value. So when x is pi, y is going to be equal to, if we pop that into here, well, sine of pi is 0. So we get y is 0. And when x is minus pi, if we put minus pi into sine x in our y equation, we also get 0. Okay, so then the tangent equations are, if you use, remember, y minus y1 equals mx minus x1. So this is easier because the y's are 0. So y is equal to the gradient, which was minus 1 times x minus pi for that first one. So that just becomes minus x plus pi. And the other one, y equals x minus pi, so x plus pi. There's our 2 equations. Now we need to find their point of intersection. So set them equal to each other. We get 2x equals 0 or x equals 0. So they intersect at x equals 0, and then putting the 0 back into one of the y equations, we'll see that y would be equal to pi. Now we've done quite a bit of work so far. Make sure you don't move on before you've answered all of the question. The last bit of the question here was to show that those tangents meet at right angles. Okay, so we have the gradients are minus 1 and 1. Therefore, the product of them will be minus 1 and it meets at a right angle. Question 2, part A, find the rate of change means we differentiate. So if we differentiate this, we get, well, ln goes to 1 over the thing that was inside of it. So that puts the 4x minus 2 on the bottom. We leave the 6 on the top and we multiply by the derivative of what was inside. So that's timesing it by 4. So we get 24 over 4x minus 2. When x equals 2, then dy by dx will be equal to, just substituting 2 into that equation, we get 4. For part B, we've got f of x is 4 sine 5x, and we want to show that this particular statement is true. So to do that, we need to find f dash of x in order to find f double dash of x. So sine differentiates to cos, and we need to multiply by the 5 that's inside that using the chain rule, so we get 20 sine 5x. Now f double dash, if we differentiate that again, oops, I should have changed that sign to a cos. Cos differentiates to minus sine. Again, we've got to times by the 5 that's inside of that, so we get minus 100 sine 5x. So then 25 f of x plus f double dash of x becomes 25 times the original, which was 4 sine 5x, plus minus 100 sine 5x. So that is 100 sine 5x minus 100 sine 5x, which equals 0. Now part C has this question, being able to understand parts of the graph. Now I love these questions because I don't think they're all that hard to wrap your head around, but you do have to get some basic understandings of what it means to be defined or continuous and those sorts of things. But then it's just interpreting the picture. Okay, so when is f of x not defined? Well, that's a fairly easy one to remember. Defined means you can tell what value it holds at that point on the graph. So where could you not pick out the exact value for that curve? It's anywhere where there's no particular thing that you could read off for it. So in this case, it's where the asymptote is, just here. There's nowhere where that graph crosses at x equals 2. So we can't say what value it would hold if x equals 2. So therefore, it's not defined at x equals 2. At all other points it is. So even where there's breaks in the graph, so like when x is 4, you can see that that is defined. It's got a filled in circle there. Same for when x is minus 1. We've got this circle up here that shows us that that's the value it would take. For part 2, we want to look for where that graph is not differentiable. Now, it being differentiable means that it's got a smooth part of the curve that we could find a gradient for if we wanted to. So with the places where it's not differentiable are anywhere where there's gaps, where there's kinks, where it's not a nice smooth curve. So we're looking for any of those breaks where we couldn't nice and easily draw and work out a tangent on it. So that happens where we've got anywhere that's a gap. So there's these this x equals 2 that we already looked at. We know if it's not defined, then it's definitely not differentiable either. We've also got this gap here, and the other one that might be a bit trickier to spot is this one just here at x equals minus 1. Because we have a hole in the graph, and anywhere that there's a hole, we can't differentiate that either. So x is minus 1, 2, and 4 gives us places where it's not differentiable. Then we want to look for where the second derivative is greater than or equal to 0. Actually, no, just strictly greater than 0, not equal to. So think about what the second derivative tells us. The derivative tells us the gradient. The second derivative tells us how the gradient is changing. So this means the gradient, if it's greater than 0, that means it's a positive number. The gradient is increasing. So not just that the graph itself is increasing, but the gradient is. So the steepness is getting more so. So where on this graph is the steepness getting steeper as we go along? So if we just follow that graph a little bit, if we're coming up from the left-hand side towards this bubble here, well, that's getting shallower as we go. So it's not there. That gradient's actually getting less steep. But if we look at the other side, as we go, that gradient's getting steeper and steeper and steeper as we go that way. And the same this one. On this side, if we look at it in the same way this side, if we go this way, we're actually starting to get shallower again. It's tailing off. So not this bit. And then if we look at this bit, as we move along, we're going shallower, shallower, shallower. So that gradient is decreasing. So the bit that we're actually looking for is just this piece here. So that's between minus 1 and 2. So that'll be minus 1 up to 2, not including because we had a strictly greater than 0 situation. Okay, what is the value of f minus 1? So at -1, what is the value defined on this graph? Well, we have that value just here. It's a 3. And next we have what is the value of the limit as we head towards 4. Now it's important we're not looking for the value of f of x at 4. We're looking for the limit as we get towards 4. So if we were just asked for the value at 4, we could do that. We could pick out this dot just here at the x equals 4 point that is defined, but we're looking for the limit. So that means what happens as you approach 4 from both sides. So if we came towards 4 from this side, we would head towards 0. But if we come towards 4 on this side, it would head towards a value of -3. So that gives us two different values if we're looking for the limit as we go towards 4. Therefore, we can't define what it is. Part D, we've got parametric equations for our curve. We want to find where the tangent is horizontal. That means the gradient of the tangent will be 0. So gradient would be 0 there. So we first of all need the gradient. So we need to differentiate each of these with respect to t. So dy by dt is 3t squared minus 4. dx by dt will be 2t. dy by dx then is dy by dt times dt by dx. So that's using the chain rule so that we can cancel out the dt parts and be left with the dy and the dx in the right places, being on the y on the top and the x on the bottom. So we put the dy by dt simply as it is, and then multiply it by dt by dx, which means we've got to flip the dx by dt, so that'd be 1 over 2t, like this. And in the question, we want to know where that happens that the tangent is horizontal, so we set this equal to 0. So we've got 3t squared minus 4 over 2t equals 0. So 3t squared minus 4 is 0. Working that through gives you t is plus or minus 2 over root 3. Now it's tempting to feel like you've finished there, but we haven't quite, because that gives us the t value, and we need the coordinates, which means we need the x and the y values. So when t is 2 over root 3, we get the coordinates by putting them back into these original equations that I've just rewritten them down here so we can keep them on the same screen. So if we put 2 over root 3 into the x equation, we will get 7 over 3, and into the y equation gives us 16 over 3 root 3. Or if you found something equivalent, that's fine, but don't do it in decimals. When t is minus 2 over root 3, we get the coordinates of 7 over 3 and minus 16 over 3 root 3. And you would probably get that marked correct if you did do it in decimals. It's just much neater if you leave it as fractions and thirds. Next we've got Matui walking along. He's 1.5 meters tall, so that right there is 1.5. Towards the street light that is 6.5. He's walking at 2 meters per second, so I'm just writing on the information that we're being given, which actually that 2 meters per second, that's the dx by dt, so that's how much he's walking towards the lamppost. So, and that's decreasing, so that's going at minus 2 meters per second. And we want to work out how his length, the length of his shadow is changing as he walks towards it. So we're looking for dl by dt. Okay, so let's get started on that. So if we want dl by dt and we have dx by dt, let's work out what we need to times it by. We'll need to introduce the l on the top and we'll need to cancel out the x on the bottom. So we need something that links l and x so that we can find dl by dx. Well, we've got similar triangles going on here, so we can link L and X. So if we take a look at the big triangle first, the L plus X on the base divided by its height of 6.5 will be an exact same ratio as if we do the base of the little triangle, so that's just L, over its height of 1.5. And then we just need to tidy that up to have separate out the x and the l's. So 1.5 l plus x is equal to 6.5 l. So 1.5x would be 5l. X will then be 10l over 3. So then dx by dl is equal to 10/3, and we can put that back into our left-hand side working. So dx by dt was -2. dl by dx, if we flip over that dx by dl, we can pop that in there. And we get -6/10. So put that back into the context of the question. The shadow is decreasing at a rate of 0.6, and then remember to put your units on. So we were measuring these lengths in meters and the times in seconds. So that is meters per second. Right, question 3a, we've got some large numbers, but they've told us not to simplify. Just go ahead and do what you need to do. So dy by dx will be equal to 4 times 2020 multiplied by 3x squared plus 10, reduce that power by 1, we get 2019, and times it by the derivative on the inside of that bracket. And I'm not going to bother simplifying anything. Alright, if the distance a particle is traveling is given by this equation here, we want to find the velocity. So this is kinematics, and we know that the velocity is the derivative of the distance. Okay, so that will be, if we differentiate this, we get 1.5 e to the 1.5t minus 8t. When t is 2, we put 2 into that equation, and you get 14.13, and put the units in, meters per second. Part C, we want to find the coordinates of any turning points and their nature. So we need to find when the derivative is equal to 0. So this one is the product rule, so we will do x times the derivative of e to the minus x, so that's e to the minus e to the minus x, plus the derivative of x times e to the minus x. So tidying that up a little bit, we get minus x e to the minus x plus e to the minus x. We want to set that equal to 0. I'm going to take out a factor of e to the minus x, and we get minus x plus 1. Now e to the minus x can't equal 0, so minus x plus 1 is the bit that equals 0, so therefore x is equal to 1. So when x equals 1, y equals 1 over e, if you put that in to the original graph function up here. And we want to determine their nature, so we need to know what type of turning point it is. And for that, I'll do the second derivative. We need to use the product rule again on the first part of it up here, that minus x e to the minus x. So we get this. And when x is equal to 1, d2y by dx squared comes out to be a negative when you substitute that one value in. Therefore, the coordinates, or the turning points at that coordinate is a maximum. Okay, we've got the coordinates, find the coordinates on this curve where the normal is parallel to this line. Okay, so if the normal is parallel to that, then the gradient of the normal will be the same. So gradient of normal will be equal to the gradient of this one that we were given just here. So that will be equal to -1/2. Therefore, the gradient of the tangent will be the negative reciprocal there. So that would be equal to 2. So dy by dx must be equal to 2. And we want to find out where that happens. So dy by dx of our graph, we're differentiating tan, that gets sec squared. Oops, x squared x, set that equal to 2, we get that 1 over cos squared x equals 2. So cos squared x is equal to 1/2. Therefore cos x is equal to plus or minus the square root of that, or 1 over root 2. Don't forget to miss out the plus or minus part. So for that to be true, we're looking for the values of cos that are equal to either positive 1 over root 2 or negative within the range that we've got. Okay, so we're looking for the range from 0 to pi by 2. So we're actually just looking for this first solution here, because that graph is going to cross over the axis. That's the pi by 2 point. So the next solutions we're not interested in. We're only interested in this first solution, which is the inverse cos of 1 over root 2. So we're going to do this. Now that is one of your special values, so you need to have an exact answer to this, and that's pi by 4. Now again, make sure you've finished your question properly. The question asks for the coordinates. So the coordinates, we need the y value as well. So that's pi by 4. If we just pop back up to look at what y is equal to tan x. So if you put pi by 4 into tan, you get 1. Okay, last question. We've got this template for creating a tent, and we want to maximize its volume. So in order to maximize the volume, we will need to work out a formula for the volume. So the formula for the volume of a pyramid is 1/3 times the base area times the height. So let's get something for the base area. Now this is 10 by 10 on the outside. The base area of that pyramid is this square that's in the middle. And that's got, this length here is x, so therefore the sides are 2x, and the area of that will be 4x squared. So we can pop that down into here. The base area will be 4x squared. Now for the height, that's if we drop a perpendicular down here. So that's our height, and this here is x. So we can use Pythagoras there. 5 minus x squared would equal h squared plus x squared. So rearrange that for h, and if we just tidy that up a bit, that h squared is equal to 25 minus 10x. So here for the height, we can put in the square root of 25 minus 10x. Okay, so we've got 4 over 3 x squared 25 minus 10x to the half. We need to differentiate that, because if we do that, we can set it equal to 0 to try and find the maximum. This is going to take using the product rule. So if I differentiate the first part, we get 8x over 3 times by the original second part. And then add on the first part times by the derivative of the second part. So times by half, 25 minus 10x, and minus half times by minus 10, which I've tidied up to this, and then let's set that equal to 0. And then we need to work through all of that. So we carry on working through that. I'm just going to do the rest of this. And we get x equals 0 or 2. Now x can't be 0, it's got to be a length, and she's got to cut some of that fabric out, so x must be equal to 2. So when x equals 2, last thing is to find out what the volume is. So x equals 2 gives maximum volume. And put that back into our volume formula. And we get the maximum volume is 16 over 3 root 5, or 11.926 meters cubed.